You know, when we think about the future of manufacturing, it often feels, well, far off. But what if I told you it's already here? And it's not being built by people in hard hats. Nope, it's being built by robots. Let's dive in. So, what if a factory looked less like, a traditional factory and more like a scene straight out of a sci-fi movie? I'm talking about a floor filled with intelligent machines that look and move just like us, doing these super complex jobs with flawless precision. Sounds like Hollywood, doesn't it?
Well, get this. That future, it's happening right now. Over in China, this isn't just a movie plot anymore. It is reality on the production line. And believe me, it is changing the game. All right, so let's get into it. Our story kicks off inside a factory, but not just any factory. This place belongs to a company that is, and I mean this, absolutely central to the whole green energy revolution. And they just announced something that's basically signaling a whole new chapter for manufacturing.
That company is CATL. And if that name doesn't ring a bell, it should. They're the world's biggest maker of EV batteries. I mean, to give you some perspective, they control a whopping 38% of the entire global market. They're the ones building the batteries for huge names like Tesla and BMW. So yeah, they're not just a player, they are an absolute giant.
But here's the thing. When you're building millions and millions of these super advanced batteries, you run into some pretty big challenges. And there's this one final step in the process, the very last quality check before a battery gets shipped out, that is not only incredibly delicate, it's also really, really dangerous.
So let's break that down. What are we actually talking about here? It involves a few key things. EOL, which stands for end-of-line testing, and DCR testing, or direct current resistance. Now, in plain English, these are just super detailed checks to make sure every single connection is perfect and that the battery is going to perform exactly the way it's supposed to. Think of it like the final exam before that battery gets to go inside a car.
And here's the kicker. This job, it was always done by people. Real, human workers had to handle these connectors that are carrying hundreds of volts of electricity. The risk of a serious electric shock, it was always there. But beyond just the danger, you have the classic problem of human error, right? When people get tired, they make mistakes. That means quality isn't always consistent. Plus, trying to switch between building different types of batteries just slows the whole line down.
So, what the factory really needed was a new kind of worker, someone or something that was fearless, never got tired, and was always perfectly precise. They needed a champion. And here it is. Say hello to Shamo, which kind of translates to Little Mo. This humanoid robot is the hero we've been talking about, developed by a company called Astrobot specifically to solve this high-voltage problem.
So you're probably wondering, what makes this robot so special? Well, its power comes from this really advanced AI called a Vision Language Action Model, or VLA. The easiest way to think about it is this. The cameras are its eyes, the AI is its brain that figures out what it's seeing, and its arms and hands are, well, its hands, to actually do things. It literally sees, thinks, and acts.
And this VLA brain gives Jamo something that feels a lot like human intuition. Let's say a battery pack isn't perfectly lined up. Jamo sees it, and it adjusts on the fly. When it's plugging in a tiny, delicate wire, it knows exactly how much force to use. Just the right touch, firm but gentle. It can deal with stuff that goes wrong, all by itself, no human help needed.
Okay, so that all sounds amazing on paper, but how does it actually perform when the rubber meets the road? Or, when the robot meets the actual production line? Let's take a look at the results. And the numbers here are just staggering. For those supercritical high-voltage connections, SIAMO has a success rate of over 99%. Just think about that. That's a level of precision and consistency that's almost impossible for a person to keep up hour after hour, shift after shift. Okay, so what about speed? Well, Zamo works at pretty much the same pace as a skilled human worker. But it never gets tired. It doesn't need a coffee break or a lunch break. And that means, especially when the factory is juggling different battery models, Zamo's daily output is a full 3 times higher than a person's. That's incredible. So what does the company itself think? What's the verdict from CATL? They actually call Zamo an indispensable member of the team. So you see, this isn't some side project or a cool experiment. This robot is a core part of how they get things done, and it's proving its worth every single day. So, okay, we've got a really successful robot. That's awesome. But what does this all mean for the bigger picture? Because this isn't just about one robot in one factory.
This is a real glimpse into a totally new era of manufacturing.
So let's break down why this matters so much. First up, worker safety. That's a huge one. You're taking people out of one of the most dangerous jobs on the assembly line. Second, you've got product quality. Fewer mistakes mean better, safer, more reliable batteries in our cars. And third, efficiency. This technology helps companies meet the absolutely exploding demand for EVs, which in turn helps speed up the entire green energy transition.
What we're really seeing here is this big idea called embodied intelligence. It's a fancy term, but all it means is AI that doesn't just exist on a server somewhere in the cloud. It lives inside a physical body, a robot that can actually interact with and learn from the world around it. It's not like one of those old-school robot arms that's bolted to the floor and can only do one thing over and over. Zamo is flexible, it's adaptable.
And that brings us to maybe the most important takeaway of all. This is not some small test run. What CATL is doing with Xiamo, this is the very first time anywhere in the world that humanoid robots have been used on a large scale for battery production. We are talking about a genuine historical milestone here.
So that leaves us with a pretty wild thought to chew on. Xiaomo, the robot, is itself powered by a CATL battery. You see that? You have this incredible feedback loop of innovation happening, which leads to the big question, how long will it be until robots are building the very batteries that will power even more robots? Kind of makes you think, doesn't it?